Number 11, it says fill in the missing information. Okay, so they gave us that it is given in standard form as the following. And it does verify because size matters with ellipses, and you see that the 100 is bigger than 36, and it's underneath the x. So it's bigger x-wise than what it is y-wise. Okay, so that 100, if I take the square root, I know that this would be 10. Okay, then y-wise, if I take the square root, I know that this would be 6. Okay, so I can see that x-wise, it was 10. So a is 10 because, again, a and b match up with x and y. And 6 is going to be my b value. Okay, so we'll say 6 here for b. We'll say 10 for a. And we know that the center is going to come from what's in parentheses, opposite interpretation. So x is a positive 10, y is a positive 6. Now the c value, because of the fact, very important, because of the fact that this is an ellipse, which is adding, I will subtract here to get the c. Okay? And size matters again. So we're going to put c squared is equal to the bigger one, which in this case is a, minus the smaller one, which in this case is b. So we'll say c is equal to the square root of 10 squared minus 6 squared, otherwise 100 minus 36, which is 64. And when I take the square root, sure enough, c is going to give me 8. So that means 8 units from here, which is probably going to end up about here. That's where one of the foci would be located. Okay? So again, my center was 10, 6. So if I'm going left and right, that means I'm going to add 8 units right here to this 10. So I'll get, let's say that this is F1 over here. I'll get 18, 6. And let's say that way over here, this is F2. I'm going to, from this 10x value, subtract the 8, and I'm going to get 2, 6. Okay, so some of you on your quiz, you put something that looks like this: 10 plus 8 comma 6 and 10 minus 8 comma 6. Please, please, please simplify this right here to give me 18, and simplify this to give me 2. Unless it's a square root over here in these places that you're adding, I want you not to write it that way. I want you to write it the most simplified form, which is what you get as 18/6 and 2/6. Alright, so the eccentricity, it's c over either a or b, and size matters with the ellipse, so it's going to be the bigger one. So we know c is 8, and we know a is 10, so it's going to reduce to 4/5, which is of course less than 1. And we know that if the eccentricity is less than 1, it's an ellipse. Okay, if it's greater than 1, which most likely will happen over here, it's going to be a hyperbola. And if e is equal to 1, it is the parabola. Okay, so the only thing that we have missing out of all this work is the major axes. So this major axis right here is size matters, so the major one is the bigger one. But it's not just this 10 value interpreting half of it. The major axis is the entire axis, which in this case would be 10 for this one, 10 for this one, for a grand total of 20 units. Okay, minor axis. Minor axis is referring to the smaller one, which we saw as 6, but it's meaning the entire thing. Okay, so it's like 6 plus 6 would give you 12. I know it's not asking the minor, but that's what it be. That's what it would be if it was asking the minor axis. Now let's go ahead and go to the hyperbola. This is a hyperbola because one of the values is positive and one of the values is negative. Most likely, you see it on your formula chart as the positive one listed first, subtracting the other one, and set equal to 1. This is probably the form that you'll see it, but either way, these are equivalent, and they both show that because y is positive, it's going to be looking up and down. Okay? All right. So let's look at what's in parentheses with the x and y, which we don't see anything. So my center is 0, 0. Makes sense. It's right here. And the vertices that we're going to look for are going to be here and here. And we have to find out what is the b, otherwise y value, from the center that gets me all the way to that vertex there, and from the center that gets me all the way to this vertex here. Okay? I need to find that jump. Well, y, it's 144, and if I take that square root, the y value is going to be 12. Otherwise, b is 12. Underneath the x, which is also the same as y, underneath the x, which is also the same as a, if I take the square root, I know that 5 is a. And again, hyperbolas are subtracting, so to find c, I'm going to add a squared plus b squared, because it's always the opposite of what you see over here, and this is going to be c squared. Otherwise, c is taking the square root of whatever that 5 squared plus 12 squared business gives you. Okay, so we get 25 plus 144, so 25, 144 is 169, and the square root of that is 13. Okay, so c is 13. All right, so the foci is going to basically be 13 units from the center. So if I went up, it'd be this 12 plus a little bit more. That's where that foci is. And 12 down plus a little bit more, that's where that focus is. So plural is foci, singular is focus. So if I'm going from this center, and I'm going up and down, that means I'm affecting this y value. I will go up to positive 13, and I will also go down to negative 13 to get, let's say, f of 1 is way up here, and f of 2, otherwise the second focus, is way down there as 0, negative 13. Okay, so the vertices. From the center, we went up and down 12. So we have 0, 12, and 0, negative 12. And then finally, we have two more left. Asymptotes and eccentricity. So eccentricity is c over whichever one is positive. Remember, order matters. So the first one that's positive, not the bigger one. I'll say that again. Size does not matter on hyperbolas. It's on ellipses that it does. On hyperbolas, like over here, it was over the bigger one. Okay, so it was c over the bigger, where here it's c over the positive one. And the positive does belong to the y, which in this case is going to be the square root of 144. So our c value was 13, and the square root of that is, square root of 144 is 12. And you can see right now this 13 halves is bigger than 1, which shows, sure enough, e bigger than 1 would show that it's going to be a hyperbola. Now we'll just finish it off with the equations. We have y minus k equals plus or minus b over a. We have x minus h. That's my equation for these asymptotes when it comes to these slant asymptotes. Right here for the positive, here for the negative, positive, negative. And all we have to do is just plug in the values. We know that our center is 0, 0. We know that our b value is 12, so that'll go up on top. And we know that our a value is 5, and that'll go on the bottom. So that we have plus or minus 12 over 5x. And it's not adding anything else because those zeroed out. And y is equal to plus or minus 12 x would be the equation. The positive 12 x would be this one. The negative 12 x would be that one going down.